Good morning, Ovid LC Middle School students. This is Mr. Woolley. And remember, the information contained in this video is intended to be viewed only by the students in Mr. Woolley's classroom. By watching the video, you agree that you will not record or share the video with anyone who's not a student in Mr. Woolley's classroom. All right. Lesson 5 today, using the identity and inverse to write equivalent expressions. All right, so we'll take a look at what we have here today. In our first example, it says, in the morning, Harrison checked the temperature outside to find that it was negative 12 degrees Fahrenheit. Kind of like what we've had lately around here. Later in the afternoon, the temperature rose 12 degrees Fahrenheit. Write an expression representing the temperature change. What's the afternoon temperature? Well, if you start out at negative 12 and then you add 12, it's going to be 0. The afternoon temperature was 0 degrees Fahrenheit. So there we go. Opposite numbers add up to 0. All right. Next up, for B, rewrite subtraction as adding the inverse for the following problems and then find the sum. So kind of like back when we worked with some of our earlier lessons in our second module when we subtracted with integers. We're going to turn it into subtraction sign into addition and then turn the second number to its opposite. So 2 minus 2 becomes 2 plus. The opposite of 2 is negative 2. So 2 and negative 2 make 0. Negative 4 minus negative 4. So it's negative 4 plus. And the opposite of negative 4 is a positive 4. And negative 4 and a positive 4 equals 0. Now this one says the difference of 5 and 5. That means subtract. 5 minus 5, or they told us to rewrite them, 5 plus, the opposite of 5 is negative 5, and it gives you 0. Same thing here. G minus G turns into G plus, the opposite of G is negative G, and that gives you 0 as well. So, what do we notice that pattern there? The sum of a number and its additive inverse, or opposite, is 0. All right. Then this one we could add or subtract if we want to. 16 plus nothing, a 0 is just 16. And then if I turn subtraction into addition, it's minus to a plus, 7 becomes negative 7, 0 plus negative 7 is negative 7. Negative 4 plus 0 is just negative 4. 0 plus d is just d. So what do we notice about that pattern? The sum of any number and 0 is that number. All right, so I'm not going to spend the time going over this one real quick. You can look at it and pause it, look at the answer, then I'll move on to the next ones. All right, now this is what you're going to end up seeing on some work later today that you'll have to do on your own. So pay real close attention to what we're working with here. It says write the sum and then write an equivalent expressions by collecting like terms, removing parentheses. So this has to be an addition problem because it says to write the sum. So 2x plus, then this grouping, negative 2x plus 3. So now, if I kind of distribute this plus sign throughout the problem, 2x plus, and then just a negative 2, and plus a 3 gives me a 3. Now a 2x and a 2x, they kind of cancel each other out because they're 0. All that's left is just a 3. So just 3 would be my answer. I don't need to put 0x. I just put 3. So it's to add 2x minus 7 and the opposite of 2x. I do a little thinking about what this is. The opposite of 2x would be a negative 2x. So my first grouping, 2x minus 7, plus opposite of 2x is that negative 2x. And then if I kind of go through and get rid of the parentheses, I got a 2x, I got a minus 7, plus negative 2, so plus my negative 2. Now a 2x plus a negative 2x gives you 0, and all that's left behind is this minus 7, or what I'm going to call a negative 7 for my final answer. Now this one gets a little trickier. It says the opposite of this grouping, 5x minus 1 and 5x. I'm still trying to find the sum, so that and means plus. But the opposite of this means the negative version of everything you see here. So negative 5x is now negative 5x, and the negative 1 becomes actually a plus 1. Think of like adding the opposite. So it turns into a plus 1. And I still got my plus 5x here. So the 5x's got rid of each other. All that's left behind was a plus 1. All right. Next up, you'll see a few more of these. I'm not going to go through every single one of these, of course, but you can get the main idea here. Set it up into addition, and then some things got rid of each other. All you left from this time was a 4b. You have the 3x plus the 1 minus 3x. So you have a 3x plus just a 1 and plus a negative 3x. And that 3x's got rid of each other. All you're left with was a 1. And up here, we have the opposite of 4x. Well, that's going to be a negative 4x, so be careful with that. And then a negative 5 plus 4x. So you get your negative 4x plus this negative 5, and then plus just a normal 4x is just plus 4x. And those 4x's get rid of each other. You're down to just a negative 5. The opposite of negative 10t, well, that'd be a positive 10t. And t minus 10t. All right, so there's my t minus 10t. Now, if I lay that all out, I get the 10t plus just a normal t plus a negative 10t. Well, the 10t's get rid of each other, and all I'm left with is just a single t. Remember, I don't need to put a 1 in front of those. Just the letter's fine. And the opposite of this grouping and negative 4v. So to add that together, now remember, if I want the opposite of an entire group, I can put a negative sign in front of it. Then it forces the negative 7 now to be positive. Then minus, and then the minus makes it a plus 4v. And then I still have that plus negative 4v. Well, the 4v's get rid of each other. All that's left is this 7. Now, we shift gears a little bit towards the multiplication. So when we multiply, remember, you can always try to cross cancel if you want. Like here, I could have divided both of those by 3 and got down to 1 and a 1, and divided both of these by 4 and got down to a 1 and a 1, and would have got 1 over 1, which is just 1. Or if I didn't cross cancel, I still get 12 over 12, which is just 1. Whole numbers, remember, I can put a 1 under them, multiply out, I can do that. Even if it's negative, it doesn't matter. I can put a 1 under that, it becomes negative 3 over 1 as I multiply through. Now remember here, negative times a negative, it actually becomes a positive answer. So negative times negative is a positive answer as well. All right, so now it says to write the product and then write the expression in standard form by removing parentheses and combining like terms. So the multiplicative inverse of 1/5. Now multiplicative inverse is something we talked about a long time ago, earlier in the year, and it's like what you might call reciprocals back in 5th and 6th grade. And 1/5, if I flip it, becomes 5 over 1, or just 5. So when you see me set this up, product means times, so it's 5 times everything you see here. So there's 2 parts that are going to work here. 5 times 2x gives me 10x, and 5 times what I'm going to treat like a negative 1/5. Well, of course, a positive times a negative is a negative answer, but 5 times a negative 1/5 is really 5 over 1 times 1/5. I got to put the 1 back underneath it when I go ahead and try to multiply with fractions. So I get negative 5 over 5, which is just a negative 1. Next up, the multiplicative inverse of 2. So 2 is technically 2 over 1, so I flip it to 1 over 2. And then I can multiply there. 1/2 times 2x. I put a 1 into that 2x. And then I get 2x over 2. Now I divided the 2 and 2 here and got down to just 1x. And I'll put the 1 in front. I have just the x. And then 1/2. If I distribute the 1/2 to the 4, 1/2 times 4 over 1 gives me 4 over 2, which gives me a 2. Now I could have cross-canceled there earlier on. I just didn't, just kind of move through this a little bit better for some people. But those of you that know how to cross-cancel can go ahead and do that. So I'm left with just an x and just a 2. So x plus 2 be my final answer. So you notice how you distribute. There's an x number and a regular number in the original problem, and then your final answers, you get 10x minus 1, x plus 2, so there's still some things there on each part. All right, we got a few more here to look at. We got the multiplicative inverse of 1 over 3x plus 5 and 1/3. Now, 1/3, if I go ahead and use that, I'm going to times something by a third, no big deal. Then I'm going to flip this, because I want the multiplicative inverse of the flip of it, which is now 3x plus 5 over 1, or what we'll just call 3x plus 5. So 1/3 times 3x over 1, because I had to put a 1 under it to multiply its fractions. I get 3x over 3, divide those 3's out. 3 divided by 3 gives you 1 of the x's, so you're left with just an x. 1/3 times 5 over 1 gives you 5/3. So x plus 5/3 would be your final, or if you want to make that from an improper to mixed, x plus 1 2/3 are the same thing. All right, same thing here. The reciprocal of 3, which would be 1/3, so we have to flip that. And I'm still finding the product, of course. I'm going to times it by this amount here. So 1/3 times a negative 6y, and 1/3 times a negative 3x. Now positive times negative is going to be negatives on both of these. So I get 1/3 times negative 6y over 1, which gives me a negative 6y on the top and a 3 on the bottom. Negative 6 divided by 3 gives me a negative 2 of the y's. And 1/3 times a negative 3 over 1 gives me negative 3 over 3, which is, or at negative 3x over 3. Divide those 3's out, you get a negative 1, or negative x, we'll say. So kind of a weird looking answer, but we do want to make sure they're in proper format, so make sure they're alphabetical. Your x is actually going to go first, so the negative x minus 2y. And then we got a couple more here to look at. The multiplicative inverse of 4, so that's 1/4, times this 4h minus 20. All right, so we can multiply that out. 1/4 times the 4h, or 4h over 1, gives me 4h over 4. So divide by 4, it clears those out, leaves just one of the h's. And 1/4 times negative 20 over 1 gives me a negative 20 over 4. And negative divided by positive is a negative. 20 divided by 4 is 5. So you got an h, and then a minus 5, or negative 5. So my final answer looks like h minus 5. And multiplicative inverse of a negative 1/6, well, I'll still keep the sign. It's still negative even when I flip it. Negative 6 over 1 is the same as negative 6. Now that negative 6 is going to get distributed here to everything that was going to be part of that grouping. So negative 6 times 2, well, that's just a negative 12. Negative 6 over 1 times 1/6 j. Well, you get negative times a negative is a positive, and you get 6, and then 6. So you get 6 over 6. Well, 6 divided by 6 is just 1, so you're left with just one of the j's. So remember, letters go first. So you're left with a j at minus 12, so j minus 12. All right, go ahead and give your practice a try in Schoology. Thanks for watching.